A warm welcome to all of you. Today we are discussing about excretory system part 3. Blood supply to the kidney tubules. You can see in this picture, yes, nephrons are there. This nephron surrounded by lots of blood capillaries. In both the kidneys, almost 2 million nephrons are present. Then each nephron surrounded by blood capillaries. Then what is the need of blood supply to the kidney tubules that we are discussing? Who will supply blood to the nephron or renal tubule that we are discussing here? A pair of renal arteries branch off from the dorsal aorta to enter the respective kidneys. What is the function of renal artery? Renal artery is supply blood to the kidney from the dorsal aorta. Yes, it will supply blood to the kidney from the dorsal aorta. Each renal artery branches, here you can see, branches and rebranches to form several arterioles. Then these arterioles, each arterioles enter into the Bowman's capsule of each nephron. Here you can see that arteriole, we call it as that arteriole enter into the Bowman's capsule. That arteriole we call it as afferent arteriole. What is the function of afferent arteriole? Afferent arteriole bring blood into the Bowman's capsule. Then this afferent arteriole breaks up several times and form capillaries, numerous capillaries, a knot of capillaries, a knot of mass of capillaries we can say. These capillaries we call it as glomerulus. Then these glomerulus reunite and form efferent arteriole. Efferent arteriole, what is the function? Yes, it will carry away blood from the glomerulus. It will carry away blood from the glomerulus. Here you can see there are numerous number of nephrons are there in each kidney. Almost 2 million nephrons you can see in both the kidneys. Then each arteriole enter into each Bowman's capsule of kidney tubules. The efferent arteriole, after emerging from the Bowman's capsule, runs a short distance and breaks up into a secondary capillary network. Here you can see, yes, the efferent arteriole. This is efferent arteriole. Then this one is afferent arteriole. Then this efferent arteriole, after emerging from the Bowman's capsule, runs a short distance and breaks up into secondary capillary network. What is it called? The secondary capillary network, we call it as vasa recta. Very important. Then which surrounds the renal tubule or nephron. This vasa recta surrounds the renal tubule and rejoining to form vein. This secondary capillary network rejoins to form vein. By uniting again and again with the other veins, yes, with other veins of the kidney, it ultimately forms the renal vein. Here you can see, yes, this is called renal vein. How it will form? Uniting again and again, these type of veins coming from the vasa recta, joining again and again and form renal vein, which leave the kidney at the median surface. Leave the kidney at the median surface here. This is the median surface. Yes, to pour the blood into the posterior vena cava. Yes, we know that this kidney is located in the posterior side. Then the renal vein pour blood into the posterior vena cava. Yes, understood? Function of the kidney. The main function of the kidney is production of urine. Production of urine. There are mainly 3 steps are there for the production of urine. They are ultrafiltration, reabsorption and tubular secretion. Very important. Ultrafiltration, reabsorption and tubular secretion. We are discussing the 3 steps in detail. The first step of urine production, that is ultrafiltration. What is ultrafiltration? We can discuss that. The blood flows through the glomerulus under greater pressure, which is much greater than the capillaries, the other capillaries present in the body. Why the glomerulus under greater pressure? Yes, the reason for this greater pressure is that the efferent arteriole, here you can see efferent arteriole, is narrower than afferent arteriole. All of you know that afferent arteriole bring blood into the glomerulus, efferent arteriole carry away blood from the glomerulus. Then this high pressure or hydrostatic pressure, high hydrostatic pressure in the glomerulus causes the liquid part of the blood to filter out from where? From the glomerulus into the renal tubules. From the glomerulus into the renal tubule. Then the filtration under extraordinary force. This filtration under extraordinary force is called ultrafiltration. And what is ultrafiltration? Is due to the high hydrostatic pressure of the glomerulus, the liquid part of the blood to filter out from the glomerulus to the Bowman's capsule, or we can say to the renal tubules. Yes. Then that filtration, we call it as ultrafiltration. This filtration is under extraordinary force. Extraordinary force, then that is called it as ultrafiltration. What will happen at the time of ultrafiltration? During ultrafiltration, almost all the liquid part of the blood comes out of the glomerulus. From the glomerulus, yes, this liquid part of blood passes into funnel-shaped cavity of the Bowman's capsule. Yes, here the fluid entering the renal tubule. Which part of the renal tubule? The funnel-shaped cavity of Bowman's capsule is called glomerular filtrate. Then the fluid entering the renal tubule is called glomerular filtrate. Where it will collect? It will collect in the funnel-shaped cavity of Bowman's capsule. Yes, it contains water, urea, salts, glucose and another plasma solute. Due to ultrafiltration, the thicker part of the blood left behind in glomerulus. The remaining part, the liquid part, is enter into the kidney tubules because of ultrafiltration. Due to ultrafiltration, the liquid part enter into the kidney tubules. The remaining part, thicker part of the blood left behind in glomerulus. Yes, this thicker part of blood contains blood corpuscles, proteins and other large molecules. Blood corpuscles, proteins and other large molecules present in is this thicker part of blood. Yes, what are the two blood corpuscles present in glomerulus? That is RBC and platelets. Why it's not leukocytes or WBC? Because it has the capacity to squeeze out through the capillaries, right? Then in the glomerular filtrate, WBC also present. But in the thicker part of the blood present in glomerulus contain RBC and platelets. These are the two kinds of blood corpuscles, right? Then that will carry it forward through the efferent arteriole. Thus, the blood processing away from the glomerulus is relatively thick because all the liquid content enter into kidney tubules. The next step of urine production, that is reabsorption. Yes, here you can see glomerular filtrate entering into the renal tubule after ultrafiltration. Then this is glomerular filtrate is not urine. It is an extremely dilute solution and it contains lot of useful substances including glucose and some salts such as sodium, etc. Yes, as the filtrate passes down the tubule, much of the water is reabsorbed together with useful substances. You know that, yes, glucose and salts. Then much of the water reabsorbed with these useful substances into the capillaries. Yes, capillaries means that secondary capillaries called vasa recta. Yes, then these vasa recta surrounds the, as you can say, this kidney tubule. Kidney tubule surrounded by these secondary capillaries. Then these substances reabsorbed some water and some useful substances re-enter into the capillaries. But their reabsorption is only to the extent that the normal concentration of the blood is not disturbed. All of you know that blood has a specific concentration. Yes, to attain that specific concentration, this reabsorption will continue. After that, yes, it will stop. Then to maintain the specific concentration of blood, this reabsorption will occur. Then that is called selective reabsorption. All of you know that efferent arteriole, this is efferent arteriole, is contain thicker blood. Then to attain the normal concentration of the blood is what is necessary. Reabsorption is very necessary. Then much water and useful substances re-enter into the capillaries. The last step of urine production, that is tubular secretion. The other two steps are ultrafiltration. First step is ultrafiltration, then reabsorption. The third one, tubular secretion. Certain substances like potassium is then larger number of foreign chemicals including drugs like penicillin passed into the forming urine present in the distal convoluted tubule. Then these potassium, penicillin, etc. is secreted by the cells present in the tubular wall. That's why that is called tubular secretion. Then this filtrate left after reabsorption and tubular secretion is called urine. Yes, we can't say the filtrate left after reabsorption is urine. No. After, yes, reabsorption and tubular secretion, the remaining filtrate, we can say urine. We can revise the steps in urine formation. First step, that is ultrafiltration. Where it will occur? It's a part of renal tubule, that is glomerulus. Glomerulus present in the Bowman's capsule. Here ultrafiltration will occur. Then the next step is this Bowman's capsule receives glomerular filtrate. Then after Bowman's capsule, proximal convoluted tubule is there. It reabsorbs most water and much of glucose, sodium, chloride ions. This proximal convoluted tubule. From the proximal convoluted tubule, what will occur? Reabsorption will occur. This is actually surrounded by vasa recta. Vasa recta or secondary capillary network. Yes, the efferent arteriole rebranch to form vasa recta or secondary capillary network. Then these glucose and other substances enter into these capillaries. Then the next part, that is loop of Henle. Some absorption of water and sodium ions. Loop of Henle, again reabsorption will occur. Here is some of the water again reabsorbed, then sodium ions also reabsorbed in loop of Henle. The next region, that is distal convoluted tubule, reabsorption of remaining chlorides and some water. Here remaining chlorides and some water will reabsorbed by distal convoluted tubule. Then the same time what will occur? Tubular secretion occur in distal convoluted tubule. Walls secrete potassium and other foreign chemicals such as penicillin and other drugs into forming urine. Yes. Then after tubular secretion and reabsorption, the remaining filtrate we call it as urine. Then ultrafiltration occur in glomerulus. Then Bowman's capsule receives the glomerular filtrate. Then reabsorption occur in proximal convoluted tubule, loop of Henle and distal convoluted tubule. These three regions, yes, reabsorption will occur. Then tubular secretion, that is the last step, tubular secretion. Where it will occur? It will occur in the distal convoluted tubule. And after that is the filtrate left, that we call it as urine. Is the next important topic we have to remember, that is urine excretion. How it will happen? Final urine passes into the collecting duct. Here you can see is distal convoluted tubule. Here urine formation will occur in distal convoluted tubule. Then this will passes into this urine will passes into the collecting duct to the pelvis, and through, here you can see the pelvis, then and through the ureter, into the urinary bladder, through ureter into the urinary bladder by the activity of peristaltic movements of ureter. Then this urine expelled from the urinary bladder. After that what will happen? This urinary bladder collect urine from the ureter. Then it will expelled from the urinary bladder through urethra by the relaxation of, we already learned that, by the relaxation of sphincter muscles located at the opening of the urinary bladder into the urethra. There what is there? Sphincter muscles are there. This will relax, yes, into the urethra. How it will relax? Under the impulse of the nervous system, under the impulse of brain, impulse coming from brain. Such process we call it as micturition or urination. You already learned that, right? Yes, you have to remember this term, expelled. Urine is expelled from the urinary bladder. Okay. We can go through the facts of nephrons, some facts of nephrons. It's tiny, so many, and so much. The total number of nephrons in both kidneys approximately 2 million. Each single tubule 4 to 5 centimeter long. Total length of all tubules together more than 60 kilometer provide large surface area for reabsorption. 60 kilometers. The total length of all tubules together 60 kilometer. Blood flows through the kidneys per minute. It is 1 liter per minute. 1 liter of blood flows through the kidney. Glomerular filtrate produced in 24 hours, that is 160 liters. Urine produced from glomerular filtrate after reabsorption per day, that is 1.2 liter. Revision, exam based questions and answers we can discuss. Write the functions of the following. First one, glomerulus. What is the function of glomerulus? Ultrafiltration or filter the blood, right? Then, next one, vasa recta. Vasa recta reabsorb useful substances and much water into the blood. What is vasa recta? Is another name of secondary capillary network. Collecting duct. Collecting duct collect urine from distal convoluted tubule and pour into the pelvis. Bowman's capsule. What is the function? Is it will collect glomerular filtrate. Then the next one, proximal convoluted tubule. Proximal convoluted tubule. What is the main function? Yes, in the proximal convoluted tubule is some water, much water, glucose and sodium and chloride ions that will reabsorb into the capillaries. That is the function of proximal convoluted tubule. In that region, reabsorption of useful substances like glucose, sodium and chloride ions and much water will occur. Then loop of Henle. In this region is some water, then chloride ions will reabsorb from this region into the capillaries. Distal convoluted tubule. What are the main functions of distal convoluted tubule? We can say reabsorption and tubular secretion. Reabsorption of what? Reabsorption of is some water and remaining sodium ions, sodium and or chloride ions. That is the function of distal convoluted tubule. Then the other main function is tubular secretion. Then pelvis. What is the function of pelvis? Pelvis collect urine from where? From the collecting duct. Define the following. These definitions are very important. You have to go through that. Yes, in this video we already discussed this. Yes, all of you learn properly. Micturition is this video also, the earlier video also we already discussed micturition. Urine, what is urine? Ultrafiltration, tubular secretion, reabsorption. These all you have to remember. These are Very important definitions. Give reason. First one, the blood flows through the glomerulus under greater pressure because efferent arteriole is narrower than afferent arteriole. The next one, renal medulla has striped appearance because of the presence of collecting duct and Henle's loop. One more question they may ask, why the renal cortex has dotted appearance? Because of the presence of Malpighian capsule. Thank you children. Have a good day. Subscribe my channel and press the bell icon. Thank you.